Let's solve minimum difference in sums after removal of elements. Let's understand the problem statement. You will be given 3n elements. You are allowed to remove exactly n subsequent elements. The remaining 2n elements can be divided into two equal parts. The first n elements belonging to the first part, their sum is sum of first. The second n elements belongs to second part, their sum is sum of second. Find the difference between sum of first and sum of second. Return minimum possible difference. That is what the expected output. Let's say sum of first is 3, sum of second is 2, then 3 minus 2 which is 1. If sum of first is 2, sum of second is 3, then 2 minus 3 which is equal to minus 1. So let me walk through the example. Let's say you have given input as 7, 9, 5, 8, 1, 3. So let's see the length here. The length is 6. So which is of size 3n, right? So then n equal to 6 by 3, so which is equal to. It means we are allowed to remove exactly n subsequent elements. So let me remove them. So let me remove that. You know that subsequence can skip the elements, but it maintains the order. So let me remove element 9 and element 1. So if you closely see, it is a subsequence. So the remaining elements are 7, 5, 8, 3. So here it is a subsequence. It skips the elements, but it maintains the order. That's what subsequence means. So let me add them. So we have 7, 5, 8, 3. Perfect. So we have 7, 8, 5, 3. Now we got exactly how many elements? 2n elements. So after eliminating n elements, you have 2n elements. The first n element sum is 12. The second n element sum is 11. The difference between both of them 12 minus 11, so which is equal to 1. So that is what the expected output. So if you look for any other possibility, obviously which is the sum is greater than 1, so that we consider only this. Before getting into actual data structure, let's understand how can we derive this. So let me move on. The input is 7, 9, 5, 8, 1, 3, right? So this is 7, 9, 5, 8, 1, 3. So which are at 0, index 1, 2, 3, 4, 5. And we know that total length is 6, but n equals 6 by 3, so which is equal to. The first what we need to do, so we need to divide this into two parts. One is left part and other one is right part. And in each part you should have exactly n elements. Okay, so I must have exactly n elements. So let me see the possibilities. Let's say first I will choose 4 elements. Okay, so if I choose 4 elements, 7, 9, 5, 8. Obviously for the second part I will have only 2 elements, so 1 and 3. So second part there is no confusion. So I have 2 elements. I can directly take that sum, which is 4. But in the left part, right, I have 4 elements. But I am allowed to choose only n elements out of it, right? So we need to divide this complete array into 2n. So first part will have n, second part will have n. But in the left part, I have 4 elements. So I need to choose only 2 elements out of them. So which elements to be chosen? Let me give you an analogy. For example, left part is 3, right part is 2, then 3 minus 2, which is equal to 1. But if I make left part as 2, right part as 3, then 2 minus 3, which is equal to minus 1. It means in order to get minimal result, right, you always make sure that left will have minimum sum, right will have max sum, so that you always get a minimal value. So in order to get the minimum value, make sure that you have, and the left sum will be minimal, right sum will be maximum, so that minimum minus maximum you always get a minimum value. So let's see how can you do that. So in this case I have 4 options, right? I have 4 options, but I need to pick up 2 elements out of it. So obviously I need to get the minimum sum on the left part, right? So that I can eliminate the maximum elements. The max elements are 9 and 8, so that I just remove those 2 elements, so that I can left with 2 elements, which is 7, 5. so which is equal to size n. Sum of these two elements will be 12. So that now we have 12 minus 4, which is equal to 8. Okay, so I have seen one possibility. So with this possibility, I got the result as 8. Now let me move on further. Instead of taking 4 elements, from left I will choose 3 elements, and from right also I will choose 3 elements. Okay, so let's go for second option. So left I have 795, right I have 813. So we know that to get the optimistic result, we need to minimize the left sum, maximize the right sum. So in order to minimize the left sum, remove the maximum elements from the left part. You see, you have 3 elements, but I need only 2 elements, right? Because n equal to 2. So obviously, I will remove the maximum element in order to minimize the sum, so that I remove max element 9, so that I left with 7 comma 5, which is equal to 12. Now let's move on. On the right part, I need to maximize the sum. So you see, on the right part, I have 3 elements, but I need only what? 2 elements, n equal to. So that I need to maximize the sum from right part, so that I remove the minimum element from the right part. So once I remove the minimum element 1, so that it will be 8 comma 3. So obviously here the sum is 11. So that if you see the difference, 12 minus 11, so which is equal to 1. Okay, so we got one answer as 1. Let's move further. Let's move further. So we have element. Now let's see the third possibility. What is the third possibility? So I will consider left part only 2 elements, definitely. On the right part, I will consider 4 elements. Okay, so on the left part, I will have 7 comma 9. On the right part, you have 5, 8, 1, 3. So you have 4 elements. So on the left part, no confusion. I have only two elements. I can blindly take those sum, which is 16. But on the right part, I have 4 elements. But I need to maximize the sum. Obviously, I need to remove the minimum element. So that minimum elements are 1 comma 3. So after removing them, I get values as 5, 8. So which is equal to 13. Now if you calculate the difference between them, which is equal to 3. Now, if you closely observe, out of all possible solutions, so this is the valid answer, so that I can return 1. Now, you understand that left will have minimum sum, right will have maximum sum, then we will always get the optimistic result. So, what is the data structure you go for? So, if you closely see, in the left part, I need a minimum sum, so that I need to eliminate the maximum elements. So whenever there are more elements, I need to eliminate the max elements, so that I go with max heap. So heap is a data structure. Max heap will return the max element in the heap in constant time. Similarly, on the right part, I need to eliminate the minimum elements, so that I can have a max elements in the heap. So that in the right part, I will go with min heap. So let's understand how can we derive this. So let me move on. Well, we have elements as 7, 9, 5, 8, 1, 3. Nice. So indexes from 0, 1, 2, 3, 4, 5. So n equal 2. Total length equals 6. Nice. So let's move on. This is my left sum. Let's take it as left sum, or you can consider it as left part. And we also have right part. So what we do, I am going with max heap, because I need to remove the max elements when the size is greater than 2, because here n equal to 2. Similarly, on the right part, I need to go with min heap, so that when the size is greater than 2, I will just remove the minimum elements. And I want to track at each index what is the maximum sum or minimum sum you can acquire. So first let me solve with left part, so that what I will do, I'll take a simple array. So left sum, let's assume it's a left sum. So the array of size 2n, because till where you can move the left pointer. So you can if you closely see, my left pointer will have at max 4 elements. Even my right also will have at max 4 elements. It means, what did you understand? So either of the left or right will always have the possibility of 2n, so out of which we need to figure out a what are the elements we need, right? So now What I will do, at each index I want to maintain what is the optimistic sum I can gain. So that first let me derive left, then I will move to the right. So the left will have 2n size, so which is going to be 0, 1, 2, 3 indexes. So let's move on. First let me derive the left part. So I am at here. So my max heap will have element 7. So if you closely see, the max heap size is less than n, so that I can consider it. As of now, I got the sum as 7, so that at index 0, the sum is 7. Let's move further. I am increasing the left. Now we are at 9. Now if you closely see, my max heap having two elements, and n is also 2, so that max heap size not exceeded, so that the current max heap size is sum is 16, so that I can keep 16 at index 1. What it is representing, if you closely see, at index 1 we have value 16. So it means till index 1 the minimum sum you can make is 16. So that's what it is speaking about. Let's move on further. So we are going to add element 5. Now if you closely see, the max heap size, right, the max heap size which is exceeding the max heap size which is exceeding the n, right? So n equal to, the max heap size is 3, so which is greater than n. So it's time to remove the maximum element, right? So because on the left part we want to minimize the sum. So left side we want to minimize the sum. That's why you need to remove the maximum element from the heap. So obviously you need to remove max element. So let me remove that. So I can remove this max element. So after removing max element, the heap contains only two elements, 7, 5. The sum of these two elements will be 12. So obviously at index 2 you have value 12. What does it mean? If you closely see, till index 2, right, if you consider these two elements, the minimum sum you can make is 12, so which you already stored. That's what we are trying to derive it through this array. Now let's move on further. You can extend left pointer one more index, because left can move up to 2n elements. So this is the last index. So you have element 8. Now if you closely see, my heap size is greater than left n, so that obviously you can remove the max element. In this case, the current itself is the max element. And obviously you have the sum of the heap is 12, so you can store 12. Now what did you understand here? Till index 3. If you closely see, till index 3, the minimum sum you could make, is 12. With two elements, the minimum sum you could make is 12. So that's what this array is representing. Nice. So we are done with the max heap from the left part. Now let's do that in the right part. How do you do it? It's purely opposite to this. So let's do that. Now this is our array, right? This is our array. So same thing. So what we do, again we are going to maintain the sum for right, so that let me consider it as right sum. And even right also will move at max 4 elements, right? So from n to towards left, right also will move at max 4 elements. If you closely see, these are the 4 elements I have at right part. So it means from last to 4 elements we can maintain, right? So that's what we need to see. Right, so here also you have, you need to maintain the sum at each index. So I am trying to do that. So 0, 1, 2, 3. Let's move on. So let's say this is my right part. So I am trying to start with index 3. So in the min heap, you only have index 3. So you have only one value. So sum is equal to 3. See, I'm traversing from last. Okay, so hope you are able to get it. Now, when you are moving on to next element, my heap contains 3 comma 1. So that heap size is less than n. So that the sum is 4. You keep the 4 into this right sum. Now let's move further. When I move to the third index, now my heap is having 8. Now I need to maximize the sum, right? So now you see the min heap size is greater than n, because n equal to 2, but min heap size is 3, so which is greater than n. So that I need to remove the minimum element from the heap, so that I can maximize the sum. So I can remove the minimum element. Now the sum of these two elements is equal to 11. So that store that 11 into index 1. Now if you closely see, this is what it is representing, right? So at index 1 you have 11, means from right the last three, with the last three elements, so what is the maximum sum you could make? What is the maximum sum you could make, which is represented by index 1? Similarly, at index 2, you have value 2, right? So value 4, right? So what does it mean? With the last two elements, what is the maximum sum you could make, which is represented by index 2, right? Let's move further. Let's move further. So we are going with the last value, which is 5. Okay. So now again, the sum is greater than n. So that obviously you need to remove the minimum element to maximize the sum, which is 3. So that obviously you get the value as 13. So that you can store 13 at index 0. It means if you closely see here, with the last 4 elements, the maximum sum you could make is 13, which is stored in index 0. Right. Now you are able to design at each index with the frequency of elements, what is the maximum sum or what is the minimum sum you could make, which can be represented by left sum and right sum. So let's move on. Let's move on. If you closely see here, we are going to take n equal to, right? N equal to. It means if you pick up two elements, if you pick up two elements from left part, you have option of four elements on the right part, right? So it means in the left part, if I pick up two elements, let me write it cleanly. So what are the possibilities you can say? On the left side, if I pick up two elements, on the right side, I can pick up four elements. Or on the left side, I can pick up three elements. Then on the right side, I can pick up three elements. Out of which we need to maximize the profit. On the left part, if I pick up four elements, on the right part, I can pick up two elements. Right? If you closely see, this is what we derived already, right? This is what we derived already. So this is the maximum, this is the minimum sum you can get through two elements, right? This is the minimum sum you can get through two elements. This is the minimum sum you can get to three elements, and this is the minimum sum you can get through four elements. Similarly, if you closely see, this is the minimum sum you can get to one element. This is the minimum sum you can get to two elements. This is the maximum sum. So on the right side, you always have maximum. This is the maximum sum you can get through three elements, and this is the maximum sum you can get to four elements. Now let's see if I pick two elements from the left part. So this is what it is representing, right? So if I mark it properly, so if I mark it properly, so this is what L of 4, considering 4 elements from left part. This is L of 3, considering 3 elements. This is L of 2, and this is L of 1. Similarly, this is R of 1, because considering 1 element on the right part, getting the max sum. This is R of 2, considering 2 elements, getting the max sum. Similarly, R of 3 and R of 4. Let's move on. Now you just need to subtract, right? So here n equal to now, so n equal to, so that you simply start from n minus 1 index, right? So if you closely see, this is your n minus 1 index, means it is representing index 1, or that you can derive through logic. So let's move on. On L2, what is the value you have? 16 minus, so if you consider two elements, you need to consider four elements from the right part. R4 is represented by this index, so which is 13, so total you get 3. For example, if you consider three elements from the left and three elements from the right, so it means L3, right? So L3 is representing minimum sum as 12, and you have R3. So the R3, right? So this is R3. R3 is representing minimum sum as 11, so which is equal to 1. And similarly, you can go for furthermore, consider four elements. So if you consider four elements, L4, so which is represented as 12, so which is represented as 12. Then if you consider four elements, you will consider two elements from the right, so that obviously which is 4, so that 12 minus 4, which is equal to 8. So you've seen all possibilities, and this is the maximum result, this is the minimum value you can get. So you can simply return 1. That's it. Hope you understand the algorithm. So while deriving the logic, we can come here and manipulate between the indexes. Let's see the time complexity here. If you closely see, what is the time complexity? So what are we doing? So this is heap, and we are maintaining two heaps. The heap size at max n by 3, right? Here also the heap size is at max n by 3. And you keep on adding and deleting elements from the heap, so that obviously you can say n by 3 log n by 3. So for each element, it is going to take log n. If there are n by 3 elements, which is going to be n by 3 log n by 3. So you can simply say it as n log n. That's it. So this is the time complexity. Let's talk about the space complexity. So what is the space complexity here? If you closely see, for heap we are for min heap it is n by 3, for max heap it is n by 3, and we are also having left minimum sum array which is of size 2n, and right minimum sum array which is also of size 2n. So if you avoid the constants all together, which is going to be big O of n. That's it. So let me go and write the code. So while writing the code, we can revisit this algorithm, and let's move on how it works. Okay. So first, one thing for sure. So this is our total length. Okay. So total length, you can call it as nums dot length, and we need n. So when equal to total length by 3, because it is 3n. Okay, nice. Now once you get the n, so let's fill the left part, then we will move on to the right part. So one thing for sure, we are going to maintain left min sum. So for clarity's sake, let me make it as left side we will have minimum sum at each index, and new integer. The size of this is 2n, right? So we already discussed about it. And in the left side, you want to maintain the minimum sum, so that we need to remove the max elements. So that obviously I'm going with the heap for I'm going with max heap, so that I can remove the max elements in constant time when the heap size is overflown. So that I can just say priority queue. So priority queue, then I'll just have element 1, element 2, so which is max heap, so that I just need to reverse the sorting logic, so that I'll just do compare of element 2 comma element 1. That's it. So it will just make sure that all the higher elements will be on the top. So I'm just talking about only left part. So let's move on. uh, so this is I'll also calculate the total of left total sum, so which is initially 0, so that I can find out in constant time. So let's move on. If you closely see here, how my left is moving, how my left is moving uh, let me move here. So if you see here, earlier we seen left is starting from 0, ending with 2n minus 1, right? So because n equal 2 and 2n minus 1 means which is 3, so that which is including first 4 elements. So left is having first 4 elements, so starting from 0 and ending with 2n minus 1, so that obviously at index 3, so that let me write that part. Okay, nice. So what we do, so for our int, I can say index, which is starting from 0, and index less than 2n. That's it. So it is going until 2n minus 1, then index plus plus. So what I will do, first I will add the current value to the left total. Okay, so left total plus equal to nums of index, and I'll also add this to the max heap. Nice. So let me add to the max heap dot add of nums of index. And if I feel if my max heap size is greater than n, so it means I need to minimize the sum, right? So obviously I need to remove the max element from the heap, so that I can just max heap dot poll, so it will get the max element which is to be subtracted from the total left. Nice. So left total becomes left total minus max dot pool. That's it. So it is equivalent to this. Hope you are able to get it. Right. Now what is our job now? So we just need to store this value into the left min sum. So left min sum. So obviously this is also starting from 0 now. So you can use the same index to store this left total. Fine. So we are done with it. So we are able to derive left part. So we are at each index we are able to maintain the minimum left total or left sum. Now let's move on to fill the right part. Let's fill right part. Okay, so let me do that. To fill the right part, so what you should do, if you closely observe, so this is more informative. So when you are moving on the right part, right, you are starting from total length, right? You are starting from index 5. From index 5 you are moving towards 2n elements, right? So you are moving towards 2n elements, which is means n equal to, so from index 5 to you are moving till n value, right? So because last 4 elements are nothing but last 2n elements. So obviously you can, how do you start it? So let me do that. How do you start it? So for right sum, so our index is going to be this total length minus 1, and it index will traverse until greater than or equal to n, right? Because n equal to, so you can simply say greater than or equal to n and index minus minus. That's it. That's how the right sum will traverse. So let me do that. So for int index, which is going to be total length minus 1, so that total length is nums dot length minus 1, and my index traverse till second index, which is equal to n, so greater than or equal to n and index minus minus. So this is the actual logic. So prior to that, what should I do? I need to take integer array, so which is right max sum. Okay, so right max sum, so which is equal new integer array of, this is also size 2n, and on the right side I need to maintain the maximum element, so that I want to remove the min elements whenever there is a overflow, so that obviously I am going with min heap. So new priority queue of size element 1 and element 2, so it should be in ascending order because it is min heap, right? So that by default the priority queue is ascending order, but to avoid the confusion I'll just keep it same. Fine. Perfect. So we have a min heap. Now if you closely see, right, I need to store, right? So whenever you are traversing for the right part, so first you calculate this total and you store in this index, right? So this index, so that I'll maintain one separate variable to refer this index, so that I can keep this total accordingly into the specific index. So let's move on. So what I'll do, so one is I have complete right total, so which is able to talk about the total of current index. And I'll also maintain right index, which is starting from 2n minus 1. Okay, this is not like this. Here it is starting from 0, so I can use the same index, but in this case it is different. So which is starting from nums length minus 1. Okay, so I'm starting from last index and moving towards 2n elements. Let's see how it works. Now first I will update the current value to the right total. Perfect. So let's move on. Right total plus equal nums of index. Then we will add this value to the min heap. Okay, so just do that. Uh, Add of nums of index. Once you add it, now if you feel like your min heap size is greater than given n. It means the size is overflown. You need to remove that minimum element to maximize the sum. So that min heap dot pool will remove in constant time. So which can be subtracted from right total. Perfect. So once it is done, what you do, you need to update this value into the current right index, which is starting from 2n minus 1. So into the right max sum, you can take this index and update the right total. Perfect. Once you've done it, you just decrement the right index minus minus. Perfect. So we were able to derive it. So one thing, they are expecting answer in long, so that let me consider everything as long. This is also long. Similarly, we have right total is wrong, right max sum also long. Okay. Now let's figure out, this is the critical logic. So find out now here we want to find out max value. So if you closely see, find the optimistic answer, right? So we already know at each index what is the value you have. If you closely see, this is my left. So left will start from n minus 1 index, right? If you closely see, this is what happening, right? So what you are trying to do, first you will consider two elements from left and four elements from the right. So two elements from left, the sum L2, which is represented by index 1. So index 1 is represented, if n equal to, n minus 1 is nothing but what? Index 1. So left will start from index 1, right will start from index 0, because in right part, if you closely see, the index 0 is representing maximum sum of four elements, maximum sum of four elements. So that's how you should derive it. So that simple, you can increment the left and you can also increment the right. That's it. So it will work. So what you need to do, what you need to do, left is starting from n minus 1 and the right is starting from 0. Perfect. So once it is done, you can also take long answer which is initially long dot max value. Then what is your job now? You will move left towards n, so the end is 2n. So because the left, we are trying to calculate from the left, from these arrays, right? So we are trying to calculate from these arrays. So I need to traverse towards, left is traversing towards n. So when you are traversing n, so you are also traversing the right pointer, so that you don't need to have two checks over there. Let's move on. So what is your thing now? So just take the answer, and let's consider what is the minimum value. So math dot min of, even this answer is minimum, or we know that the left min sum. So current left elements is represented by left. So n minus 1 means if you consider two elements, what is the minimum sum you get on the left side, minus you consider four elements, so that the four element sum is present in right max sum with the right pointer, which is right. So with the zeroth index you have four element sum, so you will just consider it. Once it is done, what is your job? Just increment the left and also increment the right. That's it. It's keep on validating, right? That's how it works, right? So if you closely see, this is how it is validated, right? First it find the difference between two, then find the difference between two, find the difference between two. That's it. So whenever you see the minimum difference, you store that value into the answer, so which is going to be your result. So finally you can simply return answer. Hope you understand the code. I know this is a pretty lengthy explanation. What is it? So illegal statement 2n. Okay, expected. Okay, so I make it as a for loop. So rather than it is while. Okay, and priority queue spelling is wrong. So let me go and update it. So that's it. It's just let me submit it. That's it. Hope you like the explanation. Please do subscribe and share. Thanks for your time. Thanks for watching. See you next time.